Ben's much better at that than I am.
So let's give him a round welcome.
Thank you. Thanks both. Something you mentioned about spaces like this being really good for people who are interested in security but are intimidated by the hacker type things really resonates with me. I think it's a great idea. I love the fact that these exist. And I've been in security for, I don't know, 10, 15 years, and I still don't go to a lot of those hacker conferences because they seem to be more hardcore and I prefer the developer scene. So thank you for putting this on and creating that space for the community. So as mentioned, we have a door. My name is Ben Dechrai and I work for Auth0. I usually have another slide that I was just about to show you with a picture of my mug, but it's right here, so I didn't need that slide. I want to talk to you today about security, naturally, that's why we're here. Specifically, thinking of different ways of how we can use existing security models to secure things that perhaps we haven't thought of before, or things that we have tried to secure, as in the case of the Amazon lock, that didn't work out so well. So let's have a look at a couple of examples. I'm picking on Amazon lock here only because they were the ones that kind of almost pioneered the space, or at least they were the organization that were the most public about creating an internet-connected door lock to facilitate the delivery of your goods behind your door. And my understanding is that it was more prevalent in the US. There are certain areas where people will drive by and if there's a package on a doorstep, they'll just get out of their car and take it and drive away. I don't think we have that much of a problem with that in Australia, but the solution that Amazon were trying to create was to allow people to have deliveries made securely and left behind their door so that nobody could steal them, which was a great idea. Obviously, there were some technical implementations that fell a bit short. So the first one happened in November 2017. This was, I think, about 3 months after, or 2 months after Amazon Lock first got released, or at least went into public use. And the issue with it was that a rogue courier who had access to your house would be able to get further access to your house without you knowing. So let's take a step through about how it was supposed to work and what actually happened. So you have a door. It's your home. You've got a delivery coming. So the delivery driver comes along in their truck and gets out and they've got a package to deliver. So what would happen is they'd get their mobile device out, which would connect off to the cloud, to an Amazon service somewhere, in order to say, I'm at the place where I'm supposed to make a delivery and I need access to the house. A code would be sent back to the device, which would be then transmitted via Bluetooth to the door. And the door would then make a connection to the internet to say, I've just received this request to open, and the Amazon service would say, yes, you're fine to open. So the final level of control was at the cloud service saying yes, a simple Boolean or a confirmation code of some sort. So the issue is that also there's a camera. So a lot of people would choose it as an optional extra to install a camera inside their house. You usually put it on like a table near the front door so that you can actually get footage of the door being opened, delivery being left, and the door being closed again. And if you're at all interested in watching these kind of videos, there are some on YouTube. They're highly interesting. And usually what happens is, because there was a lot of concern from Amazon about security and privacy of people's homes, a lot of them will not actually look. They'll just put the package down and close the door again and not even look in the house in case, I don't know, there's somebody walking around naked or the cat's thrown up or something, I'm not sure. But they wanted to make sure that people felt secure and that their privacy was being respected. So there was this camera that was allowing people to see in real time, but also after the fact what happened. So the way the hack worked is that the delivery driver could access the door, cause it to unlock, close the door again. Now the way that the door would be locked is through a Bluetooth connection again. They would send a lock signal. So the door wouldn't lock automatically. So what they could do is they could close the door, and then because the camera was connected via Wi-Fi to the home network, they would just flood the network and create a denial of service attack on the access point, which would mean the camera would drop off. The camera wouldn't have internet connection anymore. So in a lot of cases, you'd think, well, if the camera doesn't have internet connection, then surely when I'm looking at the video feed, there would be no video feed, so I'd know there's something wrong. But the way that they managed the transmission of those images was they would take a picture every, I don't know, 2 or 3 times a second. It wasn't a high frame rate, but you don't need a high frame rate for seeing somebody leaving a package. So they would take a photo every now and then, and they would send it up to a service, and your device would show you the latest photo. So what happens when the camera goes offline for a minute? You're shown the latest photo from a minute ago, where the door's closed. Meanwhile, they've opened the door again because it's not locked. They've gone in, they've ransacked your house, they've taken it all out, and if they're nice, they'll lock the door on the way out. So that was the first issue. 3 months later, 4 months later, another issue came along. So they fixed that. Essentially what they did was they changed the software so that if there hadn't been a photo sent for like 10 seconds or so, then your device would show the fact that there was no photo. So that was their solution to that problem. Then another one came along. So this one I don't think was actually done in real life, like nobody was actually robbed through this mechanism, but there was a proof of concept. Using the fact that the Bluetooth connection was used to lock and unlock the door, what would happen is some malicious person or some proof of concept white hat hacker who had no malicious intent would come along and leave a package at the side of your door. And inside that package would be a little Bluetooth transmitter, but it was off. It was also kind of detecting Bluetooth to see if there was any Bluetooth around. But of course, Bluetooth being mostly secure paired system, it wouldn't be able to read the data, but it would be able to detect if there was anything on that frequency. And then they go away and they don't even need to hide nearby. Meanwhile, delivery driver comes along, unlocks the door, puts the package inside. But as soon as they've unlocked the door, there's been a Bluetooth signal. And this little device would pick up the fact that there's been a Bluetooth signal and would activate, and then it would create a Bluetooth denial of service attack. So it would flood the Bluetooth spectrum so that when the delivery driver tried to lock the door, it wouldn't work. So you would probably expect that software on a device, when you press the lock button, that when it says locked, the door is locked. And what actually happened within the software is that the connection would time out, and then it would say locked, even though the door wasn't locked. So the delivery driver wouldn't necessarily be aware that the door wasn't locked. And then the person can come along afterwards and pick up the package from inside your house and take the package that you had delivered and also the package they left there. So there's now no evidence at all of what went wrong. And meanwhile, you come home to an unlocked door because even if they wanted to, they don't have the mechanism to lock the door. You've got an unlocked door and no package. Your cat's escaped and the dog's been sick instead. Wonderful life. So I thought to myself, there's got to be a better way. How can we use existing technologies and protocols to secure a door which, to all intents and purposes, shouldn't really be internet connected, in my mind? There's no good reason to have a door connected to the internet. But we want to have potentially the ability to have a remote system control access to that door. But how do we do that if we don't have it internet connected? So I thought, well, first step first, let's just take that internet connection out. I don't want that at all. Let's work on the basis of there's no connection at all. How do I get information to the door to be able to unlock the lock? So we have a device, and the device will make a connection to the internet for some kind of access. And in this case, we're going to add an identity provider in there. So the identity provider is going to allow the person to log in, provide some kind of credentials about who they are. And this could be automatic because, of course, the app you're already logged into. So they make a request, and in response, they get a token. And that token they can then pass to the door via NFC. NFC is a close-range communication protocol. You have to be present. There is no reason you would want to be able to unlock a door if you weren't at the door. So NFC is a perfectly valid mechanism for transferring this information. And then the advantage, I shouldn't click buttons before I'm ready, the advantage with the token that comes back, if we look at a JSON Web Token, anybody here familiar with JSON Web Tokens? Anybody understand the format of a JSON Web Token and how they self-validate? Okay, we'll go through that in a bit, but essentially they can be validated without requiring communication back to the identity provider. So the door is able to take that code and look at it and go, yes, this is valid, I'm going to unlock. So how does this work if we step back and look at how the data flow works? So we've got our devices here, we've got the mobile app, we've got the door that we want to unlock, and we've got our identity provider. So if anybody here has done any kind of OAuth or OpenID Connect type application configuration before, within the identity provider, you'll create a new application. And as part of that, you'll get 3 main bits of information that you need. You get a public and a private key, and you get a client ID. There's also a version with a pre-shared key, but we don't want to use that because pre-shared keys are usually only in environments where you trust every part of the application. And in this case, the mobile device that we're using is potentially not within the ecosystem of systems of devices that we control. So we're going to use RSA, which is a public-private key hashing signature, in order to validate the JSON Web Token. So JSON Web Token will have a header, a payload, and a signature. And the signature, based on a public-private key, will allow any system who has the public key to verify that the header and the payload haven't been modified. And that's why we can use any data in the payload with certainty that there's been no modification to it without having to connect to the identity provider to make sure that the token's actually valid. Some of you might be familiar with opaque tokens when you talk to APIs, and they're more almost randomized 30, 40, 50 character type strings. You'd have to go off to the identity provider and say, is this a valid token? And what's the scope of use that I'm allowed to use that token for? What is the permissions or the access levels that I have within the business logic that I run based on this token? But with a JSON Web Token, you can encapsulate that all inside, and the end application can verify that without talking to the identity provider, which is perfect for the door because it can't talk to the identity provider. It has no internet connection. So we have the public-private key, and the first one there is the client ID. We'll send the private key and the client ID and put that into the application that's running on the mobile phone. And we'll send a copy of the public key and we'll put that on the application that's running on the door. So the door can now use that public key for verifying any JSON Web Tokens that come back. So that's the pre-setup. Now we want to work out how the login is going to work. So obviously we're going to have a cloud component at some point because we need to log in. So the mobile application is going to launch like a web view inside for authentication, and into that it's going to pass the client ID. This allows the web view to make a request to the identity provider with that client ID and say, give me the login form for me to be able to authenticate myself. So this login form is now for your particular application. The user will then type in their credentials, send those off to the identity provider. The identity provider can then look up those credentials in its database and work out whether for that client ID those credentials are valid. And assuming they are, it'll generate some kind of authorization code. That authorization code is a short, remembered one-time password, essentially, that it'll return back to the web view, and the web view will then return that back to the mobile application. So the mobile app that you have now doesn't know what the username and password are. They were typed into the browser. It doesn't know anything about who you are other than it has this access or this authorization code. But it can take this authorization code and the client ID, bit of a stutter, and the private key, and send those back to the identity server and say, for this client ID, and with the authorization that I have by sending you the private key, does this auth code match anything that you recognize? The identity provider will say, well, the IDs match, the private keys match, and the auth code matches Ben's login. Ben just logged in now and I issued this authorization code. So what I'm going to do now is create an identity token and an access token for Ben. I'm going to return those back to the mobile application. So the mobile app now has the access code and the access token and the identity token for me, for my login, without needing to know my credentials. But we've got a full circle flow there of authorization to make sure that it knows who I am. And that access token can now be used to make requests to APIs on my behalf. So we now simply take that access token, send it via NFC to the door. And the door, having the public key, is able to generate a signature for the payload and the header. And if it matches the signature in the token that it just received, then it knows the token is trustworthy and it can act on it. Make sense? So that's what I'm going to demo today. At the moment, it's like the driver is authenticating themselves. Or are we able to make sure that who's at the door? So I still want to be able to add something like a camera in, but the camera might need internet access. But on the other hand, if we enable a Bluetooth connection between the door and the mobile device, we can use Bluetooth, which has got a higher data throughput, to take video footage, even if it's low frame rate video footage, and send it via the mobile phone to the cloud so that somebody can see that on their phone or their device. So I could see who's at my door. Again, without the door needing direct internet access. I'm not so worried about Bluetooth being intercepted or denial of service taken down. I don't know if taken down is actually a word, but we'll go with it. Because if that's not working, then I don't get a signal, therefore I know that there's something wrong. But it's not going to affect the authentication side of it, it's only the identification side of it. And then the next step after that is I want to create some kind of connection between the identity provider and the user. So when somebody arrives at the door, I can see the footage of who's at the door, but then I've got the right to say yes or no, rather than the person at the door having the right to say yes or no. Which could be done by some kind of multi-factor authentication. add in. So I'll see how I go on that. But let's go straight to the demo. So I like doing demos because they're a bit of fun. They can sometimes go wrong, sometimes more often than not. So we'll see how it goes. This particular demo's got quite a few moving parts. So bear with me while we try and get it working. So hopefully you can all see, what's that saying? You seem to be finding Visor useful. Rate Visor. No, not really. Okay. So this should be a live view of my mobile phone. Good. This is a highly secure, very vetted, pair-programmed mobile application that I wrote myself. I came up with the logo myself as well, and I'm very proud. Essentially what I did was I jumped onto the Auth0 website and I downloaded the sample code for Android, and then I found some rogue code somewhere that writes data onto an NFC card, and I mangled the two together, and it happened to work. Beyond that, I'm not a Java developer. I don't know what's going on. I also have an access card. So this is your standard NFC type access card that you'd use to swipe into any building. The only difference, of course, is that instead of having a value like this is employee number 742, and then they look up on an external system, do we have access and the door unlocks, which is how most of the systems work. This one has an access token on it, which has an expiry. Meanwhile, I also have a Raspberry Pi running over here, except there's a broken pipe. There's always going to be something that goes wrong, right? Let's see if we can connect to this again. Excellent. Did that just break something? I heard it move. Nothing like... So this is a highly secure door. There's no way to get through this door at all. There's no way around it. There is no way at all that I could get to the back system here that controls all the gubbins. You can't kick the door down. It's made of really strong fabric and plywood. But let's pretend that it's highly secure. So the way that we've designed this here, we've got an NFC reader on the front. This is connected via, actually, there's a reason why I have Visor running, so you can see a close-up. So let's do this again. And I'm going to get a camera up, so hopefully this will work. Oh, latency's awesome. All right. There we go. Is that big enough for everyone? Can you kind of make out what's going on here? Cool. If you need me to slow down or just holler. So we've got an NFC card here. This normally plugs straight on top of a Raspberry Pi. However, we don't want the Raspberry Pi on the front of the door because otherwise somebody could just short the pins and unlock the door. It's always got to be in a secure environment, right? The other side of the door that nobody can get to. So we've got the NFC reader on the front here. We've got the cable that runs through the back, which goes into the Raspberry Pi. And then from the Raspberry Pi, that cable actually splits at this point and also goes off into this little connector there. I don't know if you can make it. I'm going to turn the door around so there's more light on it. Now we're all locked in. All right, we need to get out because there's this crazy man on the stage. So we've got down here this ribbon cable goes into this little connector there, which I don't know if you can quite make out, then connects to this ribbon cable here, which is for the servo. And that servo, highly technically, moves that white plastic arm, that bit there, and pulls this very fragile metal string, which is attached via very dodgily inserted screws, to pull a piece of wood. This piece of wood here, that's actually part of a paint stirrer handle that I got from Bunnings. It's very strong. There's no way through. So, yes. Anyway. Right, so let's see how this goes. I'm going to destroy the stage first. I'm going to take my NFC card. I'm going to hold it in. Now, you didn't feel that because I'm the only one holding the phone, but there was a small vibration. Trust me on that. I'm an expert. There's a small vibration, which means it's detected there's an NFC card nearby. So I'm going to hit the login button. And if you notice, it goes off to bendechrai.auth0.com. So it's actually hitting the identity provider. And because I tested this demo this morning already, because I'm clever like that, I'm already logged in. I've already got an account. And it's, because that was a cookie, it's logged me in automatically, and it's sent the JSON Web Token back to the phone. So the Android app now has the JSON Web Token in memory. If I now click on the Create Door Pass button, you'll see at the bottom, just near the Powered By, it says Door Pass created successfully. Thank heavens for that. All right, so now the expiry on the JSON Web Token that just got sent to me is 60 seconds. Do you think I've been talking for 60 seconds yet? It's quite possible. So let me just make sure you can see both of these things, just for fun. And then I'll go back to the camera on here. Yay! All right, so the ... on the right, you can't actually tell because it's ... on every line, but it's saying that every second. It's basically I'm waiting for some kind of instruction. So if I come over here, I turned the door around, Ben. All right, so there's the NFC card reader. I'm just gonna, because this is very strong, I'm gonna just push the door in slightly so I don't break anything if it unlocks. Can you tell I'm doing well? So if I now take this card and I hold it to the NFC reader, we'll see, there we go, it expired 27 seconds ago. I was hoping that would happen. So now we've got a sort of proof of concept. We can see that the token's been passed through, access has been denied because we've got an expiry in there. So let's just switch over to here again. I'm going to have to log in again, and the reason for that is I need a new access token. If I burnt the old access token back on again, then that obviously wouldn't help. So let's write that to the card. This time I definitely need to push this in, and this time we can have a look at what's going on down here. My phone's running the Wi-Fi as well that everything's connected to, so that's probably why it's a bit slow. If I now unlock it, there we go. So you can see the door can be unlocked. And now it's locked again. So that's it. That's the demo. So what I want to do really in terms of like what's the point of what I've just been doing is we as software engineers often are in a position where we're given requirements. We're giving something that we can sell to a customer. And we often come up with ways that are a little more convoluted than perhaps need to be. There are plenty of standards and libraries out there that we could use, but whether or not we suffer from the not invented here syndrome, or whether it's just because we like the challenge of solving a problem in interesting and innovative ways, sometimes we create, in the way that Amazon did, no fault. I mean, we all create buggy code, and we all create systems that need patching and rethinking and redesigning at some point in the future. But if we think outside of the box and think, well, okay, so we're unlocking a door, but what if the door is just an API? And what if the mobile phone is just a device that somebody uses to log in to connect to an API and say, unlock me? Then we can take the existing processes and systems that we have, re-implement them in different ways that we haven't necessarily thought about before, and create something potentially interesting, definitely a lot more fun, something that you might be able to do a talk about on stage, an excuse to build a door, but at the end of the day, something that's more maintainable, more secure, and something that when you move on or when you bring new members onto the team, there's existing documentation out there already about how OpenID Connect works and how OAuth works. You don't have to learn a brand new system again. You don't have to maintain the custom code that you wrote. So I want you to take oh, there's a picture of my door. I want you to take away from this the idea that there are ways of implementing solutions that use existing processes and libraries, but it can still be fun to do it that way, and it's going to save you a lot of headaches in the future. If you want to have a look at any of the code that I've written up here, there's an Android and a Raspberry Pi library there. There's also, because for one of the talks that I gave, it turns out that if you don't put the Raspberry Pis into those metal protective plastic anti-static bags and stick them through an airport scanner, that they fry. And when you get to another country and they don't actually sell the same NFC cards, you need to redesign the whole thing from scratch and use an Arduino instead. So there's an Arduino library there as well for you if you like. I'm told that we have time for questions, and I invite any of you to come up and have a look at the door in person if you want. And I also have some like t-shirts and stickers if you want to come grab one of those.
Thank you, Ben. We also have a thank you for you.
Oh, thank you.
Yes, it was going to have a little alfoil hat, but we didn't get around to that.
That's right. I have one implanted, so if I just do that, then it's safe.
It's fine. If anyone has any questions, I'm going to make you come to me at the middle here. so that I don't have to run around the room. So any questions, please come through. You don't have to be on camera, so don't worry about that. Nothing at all? Yes. Because I have questions.
Hey, thanks, Matt. That was really cool. I suppose presumably the Raspberry Pi there, if it's not internet connected, kind of then relies on like a robust real-time clock or something in there, because I guess otherwise you could pretend it's in the past and use an old token and do a replay attack that way.
Short answer, yes. I suppose if you were concerned about that, and it's a valid concern, you could implement within the application that connects via NFC a timestamp. So you'd then be trusting the device. You could potentially encode it some way into the JSON Web Token as well, although you've got the latency between it being generated and being passed through. There are a number of ways you could get information through in terms of timing. The other issue in terms of the Raspberry Pi not being internet connected is it makes it really hard to push out updates. So if you want to rotate the public key, or you want to fix a bug or something, you're going to have to roll software patches out in a really interesting way via a different mechanism. Yeah.
Any other questions at all? Next one.
Thank you for that. That was fun. Working with Internet of Things, very low compute devices. Obviously, the example that you use cryptography to sign the key.
Yep.
Have you any experience with kind of very light crypto kind of protocols or anything like that for those devices that can't do the heavy lifting of crypto?
Another good question, and one of the issues that I was facing with the Android hack that I had to do at the previous conference. The issue with the Android devices, there's a limited amount of memory, and you can't actually store the whole JSON Web Token in there. So whereas normally you would process data as a stream, there's no point in processing it as a stream, because by the time you get to the signature, you've forgotten what the information is that you can recreate the signature for. So in that case, what I did was I used the Android as basically a serial throughput into a Raspberry Pi. If you're doing anything to do with JSON Web Tokens, the Raspberry Pi is going to give you a lot better leverage, or something with a bit more memory. I haven't had the need to look into ways of doing it all on an Arduino. Interestingly, I don't know if I'm allowed to mention this, and it's going to be recorded. There may be some news coming up about Auth0 and Android at some point in the future. I'll leave it at that. Maybe I can tell you when I'm not mic'd during the break. What was your question? Because maybe some of the people would be interested in hearing what they figured. And then you can give us the answer as well, and I can take a break.
Right. So when I was looking at it, seemed rather complex. I guess having so much communication back and forth, understanding that you get the keys initially and all of that. But when I think something simpler, when you're looking at the multi-factor authentication stuff, you get this single code and it kind of pops up on your screen for like X seconds.
Yeah.
Is there something where it can just kind of use that, where on the first communication it just verifies who you are and then just sends back that single code, and then verifies it, and it'll only work that once, and you only get it from the provider that once?
Sure. So that token mechanism is mostly transparent. It's the same way that OAuth and OpenID Connect works. There's always a lot of communication going backwards and forwards, and between 3 points, in order to close the loop and make sure there's no injection, because the mobile device, or if you're doing like a single page app, they are untrusted. They're running in a browser or on a remote device, therefore you can't trust everything that comes in is user-generated data. So you need to kind of go back and close the gap again with that authorization code and a server-to-server communication in order to ensure that nothing's been modified on the way. So it looks complex when you're looking at the flow diagram, but from the user experience perspective, all they see is a login form, and the next thing they see is whatever they requested. It's just that there's 7 hops in there instead of 3 in order to get to that point. So I wouldn't be too worried about the complexity of the authorization flow, because that's what's actually keeping you secure. In terms of two-factor authentication, making that easier, it's a similar process. So you would send a request to the server. It still needs to be able to create some kind of secure session between the untrusted user's device, the API, and the identity service. It's just now also adding on to that an SMS or a push notification or whatever mechanism you're using for multi-factor authentication as an additional step. So from a auth flow perspective is actually making it more complicated. But again, from the user perspective, it doesn't actually look that complicated. It doesn't feel that complicated, rather. Yeah.
Thank you.
That's right. Is that the answer you came up with as well?
The first part, yes.
Okay.
I guess one of the things I was trying to reason about is, you say you have a public key on each door.
Yep.
If you're mass producing these door locks, how would you manage the keys for all these public keys of these non-internet connected doors? Like, obviously you said rotation's hard because, you know,
Yeah.
it's not internet connected, but how would you manage that initial deployment?
In the same way, I guess, as you'd manage any deployment for large-scale hardware that you ship to people's houses. There's ways of burning things and having an automated process for locking in certain different API keys. Like, for example, Telstra ship out hundreds of modems every day, and the SSID and the password are printed onto the base, and it's set up automatically for that. So there's processes already within large-scale manufacturing to make that happen. I'm nowhere near the point of large-scale manufacturing, so I don't actually know the ins and outs of that yet, but I'm hoping to be there within the next 3 or 4 months. Years. Or decades, rather. One thing you could do, because if you work on the assumption that you can trust all of the locks because you create them, and there's possibly some questions about whether that's something you can assume, but let's assume that that is fine. You could potentially have one public-private key pair for all the locks. And then what we can do is, if we have a look at the POL NFC code that we have here, at the top here we've got our public key, and then here we have an audience. So anytime you generate an access code or an access token within the identity provider type, ID token, access token, JSON Web Token type thing, one of the key value pairs that you can put into, or you usually put into, an access token's payload is an audience. And the audience is basically a URI that represents the system that's allowed to consume that token. Now, of course, the JSON Web Token itself is plain text. It's base64 URL encoded, but you can decode it and read all of the data. It's not secure, it's not encrypted. You can get encrypted ones, but for all intents and purposes, they're plain text bits of information. So you don't want to put sensitive information in there. And at the same time, you could have a rogue door. Wow, never used that phrase, a rogue door. You could have a rogue door that will accept your access token, even though the audience doesn't specify that door. But that's a rogue implementation. You, as a developer of this system, would say, well, I need to make sure that I'm door number 1, therefore I'm only going to accept tokens that are issued for door number 1. So you can put that into the token as the acceptable audience for the token recipient. So you could have the same public key. Now, you might want to, if you're going for mass scale, if you're doing a deployment within one organization, for example, then maybe you can have the same public-private key for all the doors within that physical building, because it's going to be easier to update and it's a controlled environment. If you're shipping them out and they're going to be sold on the shelves of Bunnings, then maybe you want to try and find a way of doing public-private keys separately for each one. And in terms of how you do that with creating all the keys, Auth0 has an awesome API management API. An API for managing the Auth0 side of things, not the login, but actually your dashboard environment. So you don't even need to log in and create all of the applications yourself. You could script all of that. Behind you.
That's an easy one.
Thanks, Ben. That was awesome. You made the point during your talk of the value of using well-understood platforms and tools and that, so that the next guy who comes along or girl who comes along can reason about what you're doing, and etc. I'm part of a makerspace, and it seems to be a rite of passage for makerspaces that someone decides to make a system like the one on your door, probably sometimes about as secure as the one on your door.
What are you trying to say?
Yeah, very secure.
Thank you. This is actually my front door. Like, at the moment, my house is totally insecure.
There's not much furniture. Yeah, so I guess my question is, everyone keeps re-implementing the wheel.
Yep.
And are you aware of any good open source projects that say this is a door management system that we can all use, that we can all contribute to, that sort of solves a lot of
Specifically a door management system?
Well,
There's a whole niche that I never thought would be a requirement, but let's create one. I think you could probably get away with using something like Home Assistant, which is the open source platform that'll just spin up on a Raspberry Pi. You could use something like that, as well as an identity provider. If you wanted to run your own, you can get Keycloak, which is a locally running compliant ID provider. Or you can spin off into the cloud and use something like Auth0. But in terms of a particular existing framework for door management, I would say there's probably not one. I mean, there might be some for the traditional ways that doors work in terms of normal access within office buildings, which doesn't use JSON Web Tokens. It uses essentially an infinitely long-lived token that gets verified every time from a central service.
Yeah.
You might be able to find that, but I don't think that's what you're after.
Well, I was thinking more the system that manages the door latch and the RFID and all that sort of thing. Maybe making it extensible for different kinds of auth, or that sort of, maybe the tools you're talking about do that. I'm not sure.
Different types of auth would be an interesting one to add in. And in fact, there's a new one that, like in terms of auth flows, this one here is using the, I always forget the names of all the different flows. I think it's implicit. It's one of the auth flows. There's a new one coming out called device flow, which is really useful, would work well in this. The door would need internet connectivity, but it actually becomes part of that back-to-back authentication flow verification system. So it's most useful if you have like a PlayStation connected to a TV and you need to log into some systems and you're using like the controller to type your password in. It's nasty, right? So device flow will allow the display for the PlayStation or your whatever it is you've got connected to show a QR code or some kind of a URL maybe. And then by clicking on that, the device that you're using to scan the QR code becomes the authentication vector. So you log in there and the token is then passed to the device, which is why it's called device flow, and authenticates. So you've got a better way of putting your credentials in. Yeah. So if you looked at device flow as a mechanism for this, you could actually use something like push notification, passwordless authentication with a QR code and device flow, and roll a door lock mechanism that way. So I think there are so many different ways of doing it that having one system that will provide a framework or a library to support that, it's probably not out there yet. But when you create it, let me know, and I'll be happy to try it out.
I might get in touch. Yeah. Thank you. Cheers.
I can give you some inside baseball on that. From prior to working in the super secure smart home space, I worked in the physical security space. And there is actually a company who does a thing that is all offline, and in their RFID cards, they do viral key distribution. Now, that opens so many questions about how are you making sure that the viral key distribution is a key you want distributed. But theoretically, they've thought about that. But of course, it's all closed source and who knows. But the other interesting thing from a hardware perspective is there is a sort of standard called WeGAND, and that is how your reader on the outside is supposed to connect to your hardware on the inside. So it's all data. There's no way to rip that off the wall and short the lock or anything like that, so that then you have a door control panel on the inside. I don't know if anyone's made an open source panel, but wouldn't be that hard to rip off one of the commercial ones anyway, because they're basically a WeGAN thing, a microcontroller, and some relays.
When you say rip off, you mean being inspired by?
Yeah, absolutely.
So for the recording, when you say rip off, you mean inspired by. I cannot personally condone or endorse any kind of ripping off of anything.
But anyway, just in case you wanted to go exploring, that's the place to start. Most of them, because they don't have nice, pretty enclosures on them, have all the photos of their circuit boards out there. I don't think, in fairness, any of them actually consider their circuit boards particularly secretive or anything. They're all about their software. We don't have time for any more. Look, we will squeeze in one more because you got in before I said it. But then we've got morning tea. I'll come to you, seeing as I'm going to be nice now.
Thank you very much for that. It's good to see other people with circuit boards and wires going everywhere. Was there any particular security reason you associated the private key with the user instead of with the device? Because if you associate the private key with the user, you've got to get somehow hundreds of potentially public keys into these devices which aren't connected.
So the public-private key is based on the application, which is the terminology used within Auth0. I don't know how it works within other identity providers. So it's locked into the... Treat the door as the API. The API has the public key, and then the mobile device has the private key purely for being able to connect to the identity provider as a authentication mechanism.
Does that mean every mobile device would have the same private key then?
As with the question before on how you'd roll that out, you could have the same for every device and every door, or you could rotate them. You could have an application. You could have an application within the dashboard setting per implementation. Most of the time, the standard usually for rolling out any kind of mobile app is that you would use the same key because it's an application that runs but is running on this device and this device and this device. And it's a way of logging in. But of course, then you're facing the key rotation constraint. You can roll updates out to the mobile phones quite easily, but you can't roll them out to the door as easily.
Okay. I missed the fact that it was the security association was with the application, not with the user.
Yeah, it's not the user.
Okay.
Yeah.
Thank you very much.
Thank you, everyone.
We all give Ben a round of applause, and then we can go eat.